Hello, welcome to my channel. In this video, we'll look at local storage, the web API, which can be used to temporarily store data in the browser. So for the hands-on experience, we'll actually use this sample e-commerce app, which is also a progressive web app. So before we get into the coding part, let's look at the sample e-commerce app and problem with implementation that could be solved with local storage. That is like a sample use case for local storage. So let's get started. So here is the sample e-commerce app that I was talking about. And because it is a progressive web app, we'll actually be using the Chrome web browser because it has better support for all the progressive web app features. So this is a simple e-commerce app. As you can see, you have some products listed in here. So you can add them to the shopping cart. And also you can mark them as favorites if you want. And you have the appropriate indication in the snack bar below. And also you have other features like adding a new product, but this is not functional yet. And also you can view the items in the shopping cart. Then you can navigate to another page, favorites. So just a simple app with 2 pages to navigate to. So right now we're in the home page, which is the landing page. And then we can go to the favorites. But as you can see, when we get to the favorites page, the data is lost, like the item that we added to the shopping cart and the second favorite that we added, it's all lost. That is because the data is actually shared, but it gets reset with each different page reload. Because of the way we wrote the code, and the data is currently being stored in memory, so there is no backend, and it is just stored in a map data structure. And as you can see, the pages are pretty much the same, except for the data that is being loaded as part of the page. So let's go to the Visual Studio Code. So I'll be using Visual Studio Code, but you can use any other editor of your choice. So we'll just take a look at the code. So here is the code base. So we have a public folder within which we have different directories to store all the assets of the app. Like we have the source folder where all the CSS, images, and also JavaScript is stored in here. And then we have the index.html, which is the landing page. And then we have the index.html for the favorites too. So we actually don't have a backend yet in this app. It is a simple vanilla JavaScript. And we're serving this pages over a local HTTP server. And it is a node project. So if we go to the package.json, so we have the single package here, HTTP server, as dev dependencies. So the thing is, it only serves you static pages. That reason, the navigation is done by creating folders and adding the corresponding web pages in those folders. So we don't have the Express framework or the likes to handle the navigation for us. And if we go to the index.html, so it is pretty much the same like the landing page. The difference is in the JavaScript file that is needed to load different data, like just the favorites, and the landing page is all the products. So then we have the service worker part and the progressive web app features. So we have manifest.json. It's a configuration for your web app that is needed to incorporate the progressive web app features. So we give the name, a short name, configuration for different icons or different sizes, and other attributes. So then we have the actual service worker, which we need to do some background work separate from the main app thread. So we're using cache versioning, static dynamic caching here, and we also have event handlers for the service worker lifecycle. So install where we store some static resources in the cache, which are needed for the offline functionality. And the cache cleanup being done in the activate event handler. And the fetch event handler, which actually takes control of the web pages in the app. So this essentially acts as a network proxy, intercepting all the fetch calls from the web app and the internet. So the manifest.json has an attribute called scope. So this is what determines the web pages that actually fall under the control of the service worker. So if you're new to all the service worker and the progressive web app features, this app is actually being progressively built as part of a progressive web app series that I'm doing on YouTube. So feel free to check it out if you're interested in knowing more about the progressive web app features. So the link should be on the top right corner. So next, I just want to show you like where all the data is being stored, like the shared data. So if you go to the index.html in the favorites, we have the app.js there. which is also available in the landing page as well. So if we go to the index.html at the root, which is the public folder right here, that also has the app.js. So that is a place where we actually store the in-memory data within the map data structure. So what's happening right now, the problem with losing the data from one page to another is this app.js gets loaded each time, and since we're initializing each of the products or the favorite products data structures with some initial data, it's getting reset to that initial data. So what we want is data consistency of the shared data across different web pages. So local storage could be a solution to this problem, but ideally you'd be storing the data in a backend on a remote server, maybe the cloud. But for the purposes of this video to demonstrate a use case for local storage, we'll just store it locally within the browser and then access it to render data in different web pages in order to maintain the consistency. And given that we only have like 3 products in here, it is easy to demonstrate. But when the number goes up in a real production app, it won't be ideal to store it locally in the browser. So just for the purposes of demonstrating local storage, we have this particular app setup. But in actually a real production app, probably we'll store some data related to authentication in the local storage. So that was just to give you an idea and familiarize yourself with the code base that will be working in this video. Feel free to take some time to check out the code base. The code is available on GitHub and the link to the repo is in the description. So before we change the code in app.js to use local storage, let's look at the local storage API and some documentation. Let's go to the browser. So here is a page, Mozilla documentation, so where we have the API. So the local storage, it is more consistent data across different page loads, and we have few methods to actually store and manipulate data. So we have the set method, and the way you store the data is in the form of key value pairs, just like in a map. So as you can see, the key value pairs here are both strings. Then you have a get method to actually get access to the data. So the my cat in here is the key and Tom is the value. So when you want to get back the value stored for my cat, we just use that key as input in get item, and we get back the value which is Tom in cat. So same way we have remove item, we can use the key to identify the key value pair and remove it from the local storage. And we then have the clear method to just remove all the data in that local storage instance. So that is with the methods available as part of the local storage API. We go to this page, which has a little more theory or wordy description of what is stored in the local storage and the requirements. So as you can see here, it's a simple key value store and their objects. And the other important thing is the key values, the keys and the values are always strings. So if we have an object as a value, you have to convert it to a string and then store it as a value in the key value pair. So you can do operations just like you do with a normal object using the dot notation or the square brackets, but it is recommended to use the set, get, item methods that are part of the local storage API. So that is all you need to know to get started with the local storage API. And as we've also gone through the code base, let's get started with the coding. So back to Visual Studio Code. Because in local storage, we'll be dealing with objects, we'll be converting the map into a simple object. And then using the local storage API with the get, set, remove methods, we'll build our own custom API to work with the product data that we have in our app here. So the local storage API that we just discussed would be the building block. So we'll remove the new app here. We'll just make it a simple object. So that is the typical syntax, like you have the key here, the colon, and then the value, which is the product data here. Same with the rest of the items. We'll make the same change. So now we have products as an object where we have keys, which are the product IDs, and the values are also objects, which are key value pairs for different product attributes. So we do the same with the favorites too. You can actually remove the data structure for the shopping cart products because we'll be directly storing it in the local storage. You can comment it out and do the same kind of change for the favorite products here. So now we're ready with the initial data for favorites and the products in the form of objects. So now we can start writing the API. Let's just comment it here to mark the start of the API code. So we can access local storage just with the word local storage. So as you can see, it says that it's type storage. So we need to perform different operations like adding an item, removing an item, and getting an item. Since we're dealing with collections here, which is products favorites, so we need additional methods to get access to the collections as well that are stored within the local storage, apart from getting individual items within the collections. Because when we rendered the page, let's quickly go back to the Chrome browser. So when we're rendering the page, we render the data by accessing the collection and then the individual items in the collection. Also, we'll need methods to check if an item exists in the collection or not, because when we render the icon here for the favorites, depending on whether it has been marked as favorite or not, we render different icons. So when we click on it, we're actually marking it as favorite. As you can see, it is now a filled icon and not a border icon. So to do the check, we need a method that checks if the given product is available in the collection or not. And also we have some logic within the app to display some custom message if the collection is empty, like we're trying to render the products here, but if it is empty, we render a custom message. So we need a method to know the size of the collection too, just to make the decision on whether to render a list of products or just a message as an indication of the state of the collection. And just to demonstrate that, so right now the shopping cart is empty, so when we click on it, so we get this message saying that the cart is empty, and you have a pretty lady trying to get you to add products to the cart. So now if we add an item to the cart and then we go there, so you have a different display here, which is the actual data of item added to the cart and option to check out and the total. So the decision on whether to display a custom message or the actual shopping cart content is made based on the size of the shopping cart collection. So we'll need a method to get the size of the collection as well. We're back on Visual Studio Code. So let's start writing up the API for local storage. So we'll have individual methods for different operations. So let's start with the add method. Add a collection. Let's name it add collection to local storage. So because the local storage stores key value pairs, we'll need a key for the collection name and also the data to be stored as a value. So we need collection name and then collection data. Because we have two different collections, products and favorites, let's create another object which can hold the names of the two collections. That way it will be easier to maintain the code in the long run. So let's create another object. Let's name it collection names and give the corresponding names here. So we'll have products. Let's name the products and then favorites. We also have the shopping cart, so let's add that as well. So we'll be using these names in the collection names object to add the corresponding entries in the local storage. Let's get on with the method implementation. We'll use the setItem method in the local storage API. So let's access the local storage, setItem, then we get the collection name as the key, and then the value, which is the collection data. So if you remember, local storage stores key value pairs, which are both strings. So the name that we're going to provide will be a string because it will be either products, favorites, or the shopping cart. But the collection data, here we have the object. So we cannot store the object directly. We will have to convert that to a string. So we'll use the json.stringify method for that. And then we give the input object that is to be stringified. Next, let's write a method to add an entry into a given collection. Add new entry to a given collection. It's a lengthy name, but I think it's more clear. So it will take the input of the collection name, then the product ID. Since we're dealing with the product data here, each product has an ID. And that is essentially the key in the object. So if you see here in the favorites, we have the 1, which is the key. That is also the ID of the product. So that is how we're storing the data in the object and in the local storage. So we'll need the product ID there, then the product data, which will be an object. So we'll first get access to the current data in the collection. So we'll use the getItem method. So we'll use local storage again, storage.getItem, and we give the collection name here, which is the key for the collection stored in the local storage. However, we actually stored it as a string, so we need to convert it back to an object. So we do that with the json.parse method. That way we get access to the actual data, which will be easier to work with. So now that we have the current data, we now add the input data, which is product data, to update the collection. So we do that with the normal operation on an object to add the key value pair. So it will be current data in collection. You can give the product ID and then the product data. So with that, a new entry is created in the object, and now we can add it back to the local storage. So we do that with the setItem method again, local storage dot setItem, and we have the collection name there. Again, we stringify the current data in collection so that the updated data is stringified and stored back again. So those are the two add methods to add a collection and an individual entry in a collection. Next, let's add methods to get access to the entire collection data and also the individual item in a collection. So we'll be using the getItem method of the local storage API. Let's start with the collection. Let's name it getCollection from local storage. And we just give the collection name here. So here, let's just get the data from the local storage, convert it to an object, and then return it to the caller. So let's get the data first. So we use the getItem method here, the local storage, with the collection name, and we parse it again to convert it back to an object with json.parse. Then we just return. So that is the method to get the whole collection. Next, let's write the method to get a single entry with a given ID from the collection. So let's name it getItem from collection in local storage. It takes the collection name and the product ID of the desired item. So we get the current data from the collection. It's like put it in here. So I'll just copy paste that. So once we have the object, we'll just return the matching item for that product ID. So current data in collection, product ID. So that would return the matching data for that product. So that is with the get method. Then we also want to know whether a given item is part of a given collection or not. So like we discussed before, that is necessary because based on that, we render different icons on the web page. So it will be a boolean, the return value. Check if an item is part of a given collection. Let's name it is item in the local storage collection. So we get the collection name as input. And also we'll need the product ID, so based on which we do the search and determine its presence. First we get access to the collection, convert it to an object, and then we do the search to check if product with the given ID is part of the collection or not. So let's get the data in the collection. So let's get access to the values in the object, the current data in collection. So we use the methods from the object API, object.values, and we give the name of the object there. So this actually gives back an array. Let's quickly go to the documentation. So we're using the object.values method here. So it returns an array containing all the values. So once we have access to the array, then we can use the find method, which is here in the array API, to do the check and see if it exists or not. So if it is not found, we get undefined as a return value. So we can use that to formulate our check. So back to VS Code. So here we have access to the array, and then we use the find method. And in the find method, we actually have to give the logic for the check. So here we get access to each value, which is the product. So let's say product entry. So for better readability, let's put this on the next line. And then here we need to give the check. So what we're looking for is for a product with the input ID, which is the product ID. So we'll just write down the check. So return product entry.id equals product ID. So that is a check that will be run on every entry accessed in the find method. So here, if the entry is not found, we get a return value of undefined. So here we need to do not equals undefined, because that is when we know that we have found an entry. So if it is equal to undefined, it will be a false. So we just return that, and that satisfies the check on the presence of the entry with the matching ID. Next, we write the method to get the size of collection, get a given collection. So let's name it get size of collection in local storage, and we get the name of the collection as input. So because this is also a get method, why don't we place it together with the other get methods we just wrote above? So here, as usual, we get access to the current data in the collection. Just copy paste that. Once I have that, I'll again use object.values so that I get that array, and then I'll use the length of the array as size of the collection. So object.values, then the name of the object. So once I have the array, I return the length. So that would essentially be the size of the collection. So we're done with the size as well. So all that's left is the remove method, like removing an item from a given collection. So remove given collection. Let's give that name to the method as well. So we get the name of the collection as input, and also the product ID. So let me scroll up a bit. We can get access to the collection as usual. Once we have that, we actually don't have a specific method to remove an entry from an object. So what we do is we create a temporary object by filtering out an item with the given product ID, which is the product ID, and then add it back to the collection with the updated data. So let's create a temporary object. Let's name it filtered product collection. Since we're dealing with products here, let's initialize it to an empty object. Now we'll again use the object API. We'll use object.entries. So let's quickly go back to the documentation of the object. So if we go up, so we have the object.entries here. So it returns an array containing all of the key value pairs. So what we get is the key value pair like in an array. So we can use that to filter out the product with a given ID. So we'll actually chain the for each method in the array API, since we get back an array with the entries. And with for each, we actually apply that check on each entry, like whether the product ID matches or not. And if it doesn't, we just add it to the temporary object. So that way, we filter out the entry with the matching product ID. So back to Visual Studio Code, let's write it down. So object.entries, give the name of the object here, and we get back the array. So then we use the for each method. So the for each will have access to that key value pair in an array. So product key, product value, and in here we do the check. So if the product key is actually the product ID, if the product key is not equal to the given input product ID, that is the input there, so we have the same thing here, then we actually add that entry to this temporary object here. So that is how we're filtering it. So filtered product collection and product key equals product value. So this actually adds the entry to the temporary object there. So once we're done with the for each, we would have added all the entries apart from the matching product ID. So now what we can do is we can remove the existing entry from the local storage, remove item, so that is the method from the local storage API, and we give the collection name. So that will remove that collection entry from the local storage, and now we add it back with the updated object. Of course, we stringify it. That's that item, collection name, then JSON.stringify, and we give the temporary object. that essentially completes the removal by adding an updated data entry to the local storage. So these are all the methods that we need to handle different operations that will be carried out in the application. So now we need to use this API in the products and the favorites page to store and access data from the local storage. So we also need to initialize it because earlier we were using the map. Now we need to initialize the local storage with the initial data, like for the products here, this whole thing, the object, and also the favorites here, single favorite. So let's do that. Let's initialize the local storage with that initial data. So we can use the API we just wrote. We'll use add collection to local storage. So that takes in the collection name and the collection data. So since we're going to add the products, so we'll use the object that has the collection names dot product. That is the name of the collection, and the data is actually that object that we have here, which is products. So we just add it here. That should add or initialize the local storage with this products collection. So same way we do that for the favorites as well. So just copy paste that and change the input. So instead of products, we'll have favorites, and instead of this products object, we'll have favorite products. So that is the object with the initial data for the favorites. So we have written the local storage API, we're also using it to initialize the data here. And now let's update the code in the products page, which is the landing HTML, like index.html here. So we need to go to product listing, which handles the JavaScript part, and same with the favorites. So we need to update the favorites listing.js as well. So let me go to product listing, and wherever we use the products or the favorite products directly, we'll change that to use the local storage API. So if you're not able to follow, I would recommend spending a few minutes going over the code base so that it gets easier for you to follow. The link to the GitHub repo should be in the description. Okay, so let's get started. The first change would be in the isFavorite method. So here we're checking the favorites collection and seeing if the product with the given ID is part of the collection or not. So we have created a method for that. So let's change that. Is item in local storage collection, and in addition to the product ID, we give the name of the collection as well. So it will be collection names dot favorites. One thing to note here is that even though collection names has been declared in app.js right here, we're able to access it in product listing.js. That's because in index.html we have included both the JavaScript files in a particular order. So we included the app.js first and then the product listing.js. So for that reason, we're able to access that object in a different file. So that's how the scoping works within the web page. So same with the index.html in the favorites. So we have the app.js there, and followed by the favorites listing.js. So same way we should be able to access the collection names in favorites listing as well. So back to product listing. So the return value is Boolean, so that should reflect the use of local storage here. So if we go down, so here we use the shopping cart products.size. So because we have a method to access the size of a collection, we can use that here. So the collection would be shopping carts collection. So we have a method for that. Since we're using it in multiple places, let's store it in variable. So let current shopping cart size equals get size of collection in local storage. So here we give the collection name, which is collection names dot shopping cart. So that should give us access to the size, and we can just use that in different places in the code. So in Visual Studio Code, we can actually make multiple changes at once by using the Alt key and clicking in the places that we want the change. So you see the cursor there. It is blinking in 3 places now. So this is a neat way to make changes to multiple places at once. And shopping cart size. So that's kind of neat. So let's scroll down, see where else we can make changes. So here we have the shopping cart products.values. So it is using the shopping cart collection. So here we first need to get access to that collection data first, and then use it in the for loop here. So we can use the corresponding get method there. So let current shopping cart data equals get collection from local storage. And here we give the collection name again, which is collection names shopping cart. So we are actually converting it to object within this get collection method. So if we go to app.js and go to that get method, so we're actually taking in the collection name, parsing it. So it's already being converted to object and then being returned to the caller. So that way we can directly use the object data. So here you see we have dot values. That doesn't fit well with the object API, so we need to change that. So here what we do is we give the object just like we accessed object.values in the local storage API, and we give the name of the object here. So this should give access to the individual items like from the array, so the rest of the code should work. So that is another change. Let's save it. So let's come down a little bit and see for other places that need the change. So here we're using the products collection, so we need to get access to that as well. So get current product collection data, and use the same get collection from local storage, use the products collection there, and make the same change to use the object API. So that's another change. So here we have the click event handler for the shopping cart button. So we use the shopping cart collection here. And here we need to use the get method to get the product data from the shopping cart collection. So we use get item from collection in local storage. So apart from the product ID, we need to give the collection name here again. Collection names, shopping cart. And here we're setting the updated data in the product collection, the shopping cart collection. So we use the add method here. So add or update is pretty much the same method when we deal with objects there. So we do add new item to collection in local storage. So here we have 3 arguments. So collection name, product ID, and product data. So we already have the ID and the data. We just need to add the collection name there. So this is how we check the lines of code that use the order map and change it to use the local storage. So hope that gives you an idea of how the local storage API can be used within the context of this e-commerce app here. So let me finish the rest of the changes in product listing.js and favorites listing.js and be back to test it out. We have finished the necessary changes in the favorites listing as well to use the local storage API. So with the necessary changes done, we actually have to update service worker too. So since we're using caching here in the service worker and using the cache versioning, so this is a way to ensure that only the latest version of the files are cached and rendered in the web app. So since we made changes to the JavaScript files here, so product listing and the favorites listing, and also the app.js, we need to make necessary changes here. So just update the version of the static and the dynamic caches here. So once you've done that, you just need to save it. So this will trigger the installation of the new version of service worker and thereby the new version of any files that have been changed in the code base. So let's go back to the service worker. So we're in the service worker section. Let's refresh it. So we seem to have an error here. So it's originating from product listing.js line 14 and to app.js line 82. Since we have a null or undefined value there. So let's go to product listing.js first. So line 14. So here it's with the shopping cart. So it seems like when we're trying to get the size of the collection in the local storage, we have reference to a null here. So if we go to app.js line 82, okay, so we have the get size here So I think the issue is with the initialization of the shopping cart, because here we're only initializing the products and the favorites, but we don't have an entry in the local storage for the shopping cart. So even though we don't have any entries to initialize, we need to have at least an empty object signifying that the collection is empty. So let's do that. Let's add another line here, and we'll just give an empty object here. So this should be shopping cart. So I hope that fixes the issue. And since we have made a change to the code, we again need to make a change in the service worker. So let's update the static cache here, because app.js is actually part of the static cache. You can just update that. Let's save it. Let's go back and refresh it, see if that fixes the issue. Okay, we now seem to have the products being rendered. Let's refresh it again. Yeah, so that was the issue. We just had to initialize the shopping cart collection in the local storage. So we can actually see the entries in the local storage here in the dev tools. So you see we have the domain name here, localhost 8080, and you see we have the products there. We have the 3 entries for the 3 products, and the shoes, sunglasses, and the retro camera. So seems like we're able to access the local storage and store data in there. So you see the shopping cart, it's empty. And if you go to the favorites, you have the single entry there with the shoes marked as a favorite. So let's try to make some changes here, see if we're able to see those changes in the local storage. So let's add some entries to the shopping cart. So you see we have an entry in the shopping cart here. Shoes have been added, and let's try to add retro camera. See, we have the retro camera also being added to the shopping cart. So seems like we're able to make the changes. Yeah, let's add a favorite too. Retro camera, go to favorites. Yeah, see the retro camera there. Now let's try the delete as well. So if I click here, it should remove the retro camera. Apparently there seems to be some error. So we're not able to delete the favorite from the favorites collection. Let's go back to Real Studio Code and see if we've done something wrong with the local storage implementation. So we're in app.js, and if go to the method that checks if an item is in the collection or not. So the code seems to be fine here, and same with the remove. We are creating a temporary object here and filtering out the product that matches the input product ID. So with the local storage, the code seems to be fine. Let's go to the product listing and go to the handler for the favorite click event. So we're checking if the product is a favorite or not here, which is outside the click handler, and then we're using that value inside the click handler. So that seems to be the issue. So let's change that. Have another check inside the click handler as well. Let's save it in some variable that current product status is favorite, and let's use that in here. So we're using it in multiple places, so we have to make multiple changes. Again, we use the Alt key to mark those places. So just those 5 places. Let's update it, save it, and update the service worker. So since it's part of the static cache, we just update the static version there. So let's save it, go back to Chrome browser. So with the storage, let's clear all the storage here and go back to service worker section. Reload again, just to make sure that everything is loaded fine. Okay, seems like we have the latest version. Now let's try to add a favorite. So we have the favorite there. Now let's try to delete it. Okay, so let's go to the favorites. Now you see we only have the shoes there and the retro camera is removed. So that was the issue. So it was issue with the prior implementation of the app itself and not local storage. So let's add a couple of products as well. Retro camera. Now let's see if the local storage implementation fixes that issue of data being reset in a different page. Let's go to the favorites. Let's reload. See, we still have the same issue. So we see that the data is being reset because with the local storage in place, we should have the data consistency for the shared data. So why do you think that is? So if we go back to the app.js file, there we were actually setting each of the collections with some initial data. And if we go to both the web pages, this is for the products. So we have app.js here and also the favorites, which includes app.js. So each time we load a different page, the app.js is loaded again, and it's actually resetting the collection data. So what we need to do is we have to check the current state of the collections, and only if they're empty or undefined, then we initialize the collections with the initial data. Otherwise, we just take whatever is the current state and initialize the collections with that state in the new page. So that way we'll be able to transfer any changes from one page to another. So additionally, what we need to do is we just need to capture the current state of the collections, all the three collections. Current product collection data. So we can use the get method for that. So get collection from local storage, and we give the products here. We do the same for the other two collections too. So favorites, then for the shopping cart. So now, instead of directly assigning it the initial value, we use the current collection data to make the decision. So check if it is a valid value or not. So if it is a valid value, we just assign that value, which is the current state. So that way we won't be losing any data. So same with the favorites. So if it is valid, we just set that state. If not, we initialize it with that initial data. And same with the shopping cart. So for better readability, let me rearrange the code in here. So let's save it. So I think you can read it more clearly now what we're trying to do here. Just checking the current state, and if it is valid, means it's not null or empty. That means there were some changes from a previous page, and we just assign it here. Otherwise, just use the initial data for different collections. So this should fix the issue, and let's update the service worker as well. Now let's go back to the Chrome browser, clean up the storage, then go to service workers. Let's go to the home page. So let's refresh it again. So everything seems to be loading fine. Let's the code change now. So we add items. We also mark a new favorite. So now let's go to the favorites page and see if we're able to retain those changes. So let's refresh. So now you see we're able to retain the changes. Even when I refreshed, we have the two items in the shopping cart, shoes and retro camera, and also the new favorite, retro camera. So the code seems to be working fine, and this is a possible use case for the local storage to maintain that shared data consistency across multiple pages in an app. That's it for this video. Hope you found this project-based approach helpful in understanding the local storage API and how it can be used to retain data across pages and sessions. So like I said before, this is kind of a sample use case, but in the production, the dynamic data like the product data will most likely be stored in the backend on a remote server or the cloud. So a more plausible use case would be storing authentication data or the links based on which multiple pages can be rendered with appropriate content. So the sample e-commerce app is part of an ongoing progressive web app series that I'm doing on YouTube. So if you're interested in knowing more about progressive web apps, do consider checking it out. So it should be in one of the related videos toward the end. So thanks for watching, and hope to see you in the next one.